Hey guys, BuildZoid here, and today we're going to be taking a look at another DDR5 overclock with Ryzen 7000. This time we're on an ASUS ProART X670E creator motherboard, and I bought this motherboard on eBay, so big thank you to the channel supporters for making purchases like this possible. Now the CPU I'm using is a 7900X, which was provided by AMD, so big thank you to AMD for the CPU, and the memory kit is a G.Skill 7800 CL30, is a 2x16 7800 CL36 kit. That was provided by G.Skill, and the ICs that it uses are Hynix 16 gigabit A die, so it's a single rank memory kit. Now then, the original plan for this set of parts here was that I wanted to do 6200 CL24. Unfortunately, even though this board does allow very high memory voltages, which is really cool considering that it's like a workstation type motherboard, but yeah, like this board allows the memory, like the VDD voltage for the memory to go all the way up to like 2 volts and higher. The thing is that even with like 1.9 volts, CL24 at 6200 simply wouldn't be stable. And it's not an issue of this memory, of like this G.Skill kit. I tried the Kingston kit that I have as well, right? The Kingston kit that I used in the previous like 6000 CL24 video. Yeah, I tried the Kingston kit, I tried this G.Skill kit. The G.Skill kit's actually stronger than the Kingston kit for, well, just in general. But yeah, neither of them would do 6200 CL24, and I suspect the reasoning for that is that basically once the voltage gets that high, it's actually negatively affecting stability because like I couldn't run any extended like it would run for a bit and it would inevitably error out at some point. So I did end up eventually giving up on that. So, you know, it's not really that disappointing because the practical benefits of like CL24 versus CL26 are basically non-existent. It was more like it was mostly just a case of like, well, 6000 CL24 works at like 1.75 volts. So what would it take to do 6200 CL24? And the answer is it just doesn't work as far as I can tell. Like I couldn't get it to function. And so I kind of gave up on that and decided to go for something a little bit more sensible. So 6200 CL26. That's my definition of more sensible. Anyway, as you can see, it's run, over 2 hours of Y Cruncher. In fact, I ran even more Y Cruncher than this, but there was a weird issue with the previous Y Cruncher instance, which I think was because I had Karhu open. It ran really slow. Like it wasn't doing, the performance was like really low. And I think that was just because of some kind of software conflict because yeah, this ran, properly the entire time. So yeah, like all of these are 1.56, 1.57. So yeah, that was evidently just some kind of software issue due to like what order I ran the tests in, which is always fun. But anyway, so yeah, Y Cruncher passed, and that's well over 2 hours. And actually, if you included the run that I scrapped because it was like not spitting out the numbers that I wanted to see, that was I think like a 4-hour run. So anyway, a whole bunch of Y Cruncher, 12 hours of Karhu. You can see the memory timings over here. And we're gonna take a look at them more in depth in the actual BIOS because there's certain settings that don't show up here. It's kind of that. Also, I do have a fan on the memory because we are running for CL26. You do need to run some pretty high VDD. I don't think 1.65 would actually be completely necessary with these memory sticks. It could probably go a bit lower, but yeah, I wouldn't be like with a fan on the memory sticks. I wouldn't be concerned about this like whatsoever, basically. Yeah, so. I think that's everything that worth looking at in the OS. I don't think I have any viable benchmarks on this system. Yeah, no, I don't. So yeah. The thing like so the thing about like running memory benchmarks to me is like if you punch in good timings and you run a memory benchmark and your like your performance is bad, it probably just means that you have some kind of software issue, right? Like so anyway, like I don't see much point. Also, these timings really aren't that special. Like the cast latency is pretty low, but other than that, I'd consider this quite generic Hynix timings. So Yeah, I don't really know why you'd want to see benchmarks. It's like this isn't anything that hasn't been done before. So let's restart the system, I guess. Because I can't, yeah. I guess I'll commit to this take at this point. Now, one thing that is somewhat annoying about this board is that it doesn't have a postcode, but at the same time, it is an AMD system, so it's not like the postcode is that useful. But it is, like, it's disappointing that, like, I think the retail price for this motherboard is approaching, like, £500, and it's not, like, it doesn't have a postcode, which is kind of ridiculous. Especially when postcodes used to be a standard feature of the workstation lineup from ASUS. Like, if you go back through, like, past ASUS motherboards and look at the workstation boards, they had postcodes. That was a standard feature because, like, you know, if you have a workstation and it doesn't boot, you might want to know why it doesn't boot so that you can fix your workstation. At least that's the justification ASUS had for, like, including postcodes on their workstation series motherboards in the past. And so now we have, like, workstation boards from ASUS that don't have postcodes, which just doesn't really make any sense if you think about it. But anyway, so let's take a look at the settings here. So I did actually try even higher FCLK, but I still get sketched out by the, like technically this ran at like 2200, but it's really hard, like proving FCLK stability is a pain, and 2233 doesn't work at all. So I have, like, serious, like, I find that weird, considering that, like, my 7800X3D, which, like, actually works at, like, 2200, that chip also kind of works at 2233. So I find it weird that you'd have a chip where it's like, oh, it doesn't work at 2233 at all, but it does work at 2200. So anyway, and then I actually ended up backing down the Infinity Fabric from even 2166 all the way down to 2133. Because for a while, I couldn't, like, I was having these, like, really rare errors showing up that were showing up, like, a few hours into the stress test. Turns out that was either TRCD or TRP doing that, so technically I could probably bring the FCLK back up now to, like, 2166. But the performance difference between 2133 and 2166 is, like, not very big, so you know, like, I don't feel like dealing with hard-to-track down stability issues when they don't really make that much of a difference. So, anyway, though in this case the issues were actually caused by me just trying to run, like, I was originally trying to get this to work, and that was, like, not, like, that would just fail the stress test after a long enough runtime. So, yeah, ended up testing with 3630. Yeah, because I was kind of hoping that, like, these G-Skill DIMMs would be somewhat better for TRCD than the Kingston ones, but yeah, no, like, these also, like, the TRCD on both of these kits actually behaves extremely similarly. The cast latency seems to require a bit less voltage on the G-Skill DIMMs than on the Kingston ones, but for TRCD, they're basically the same. Anyway, in terms of voltages, the SoC is at 1.23. And that's another reason why I was, like, reducing the FCLK, is because, in my experience, the FCLK scales negatively with SoC voltage. So the more SoC voltage you run, the less stable the Infinity Fabric gets, and the lower the speed that you need to run it at for stability. And so with the 7900X, previously, like when I was doing the 6000 CL24 overclock, and also just historically running this chip wouldn't really go over 2100. The new AGSA has, like, drastically improved the Infinity Fabric stability, but I haven't, like, I need to do more testing on that before I actually trust it, because it is very easy to set the Infinity Fabric to, like, settings that aren't actually stable and then have very weird issues because of it. So, like, and I'm approaching this very much as, like, a more, like, a daily stable settings rather than, you know, like, benchmark settings. Because for benchmark settings, if it runs and it spits out the score you want, then who cares how unstable it is. But for a daily system, it needs to not crash, as far as I'm concerned, right? That's, like, it's not really a daily system if it goes down at random. So, yeah, that's my approach on that, and so that's why the Infinity Fabric, like, it's probably not maxed out with this BIOS, with these settings right now. But yeah, like, I need more testing on that. Also, if you're wondering about what's up with the SoC voltage reading, that is, like, why is it, like, 30 millivolts above the SoC voltage setting? There's a very simple reason for that. The voltage measurement point for the SoC voltage on the motherboard is, like, really close to the output of the actual SoC VRM, which means it reads really high relative to the actual, like, voltage that the CPU is getting, because the SoC power plane is relatively, like, narrow and so relatively high resistance, and also the SoC power goes into the CPU through very few pins in the socket. There's not that many pins dedicated to SoC power to the actual CPU, so there's a pretty significant voltage drop across the SoC power plane, and the Super I/O voltage, like, measurement, like, voltage sensor that's actually giving us that SoC voltage reading, yeah, that's hooked up, like, way far away from the CPU, so it reads really high. So that voltage reading right there is just, like, that's just a measurement error. And I might make a video showing that in practice later, but yeah, like, that's, like, a very, very common issue with Super I/O voltage readings, is that they're really inaccurate, because the Super I/O is really not, like, it doesn't matter if that chip has good voltage readings, because the important one is the actual VRM controller itself, and the VRM controller gets its voltage readings directly from the CPU. So the VRM knows what the voltage is. The Super I/O has a vague idea of what the voltage is. And that vague idea is 30 millivolts higher than what it actually is. Because, yeah, and the reason I'm so confident that it is actually 1.23 volts right now is because we're sitting idle in the BIOS, and the VRM should have absolutely no problem maintaining a steady 1.23 volts while doing nothing in the BIOS. I've not actually measured it myself, but that's based on past experience with motherboards. Like, there really shouldn't be any, like, error in the output voltage while we're just sitting idle on the BIOS. You know, I wonder if the Super I/O reads higher than the back of the CPU socket, because that is actually really high. Yeah, so I might do something to, like, hook up a bunch of different voltage probes to this board, if people are interested. Anyway, VDDIO at 1.35, I've just found this to work well on this motherboard. There isn't, like, yeah, like, this is one of the... So VDDIO is the voltage for the actual, like, that the memory controller uses to talk to the memory sticks. And as for what is a good, like, so for long-term longevity, I probably wouldn't set this over... Yeah, I think I don't know. Like, with Intel CPUs, you have, like, the Intel equivalent of this voltage would be VDD2, but that memory controller also deals with DDR4, whereas this is, like, a DDR5 memory controller on a completely different manufacturing process. So I would personally just kind of stick to below, like, 1.4 volts or less. Yeah, ASUS, based on their color coding, seems to think all the way up to, like, 1.55 volts is probably sensible, but there would, like, I don't know how much I don't know how they came to the conclusion that, like, up to 1.55, like, that, like, 1.56 volts, 1.58 volts deserves to be red. Like, I don't know how they came to that conclusion for the color coding, so, yeah, I'm gonna err on the side of caution and just say, like, 1.4 volts or less. Also, in my experience, there's very little reason to use, like, more than 1.4 volts on VDDIO. Yeah, I don't think I've ever actually run into a setup where that was necessary. So, anyway, miscellaneous voltages on auto, because the miscellaneous voltage, basically, it just powers, like, the VDDG voltage regulators. You don't have to really worry about it. Like, by spec, it's supposed to be 1.1 volts, and as you can see, it too is off by 30 millivolts because it's being measured by the Super I/O. Yeah, so no reason to change that, because that does, like, this is, like, a power supply for the actual like, VDDG voltage regulators. By spec, it's 1.1 volts. The only reason you'd ever want to like, raise this is if you wanted to run, like, insanely high VDDG voltages for some reason, and in my experience, there is never really a reason to do that. Yeah, like the VDDG voltages really don't, like, actually setting them too high can be more, like, generally is going to be more detrimental to stability rather than helpful. So no reason to adjust that. I have the high DRAM voltage mode enabled because we're going over 1.43 volts on the VDD voltage. We're all the way at 1.65. And as long as you have a fan on the memory sticks, I think 1.65 volts VDD is perfect. At least for Hynix memory chips, should be perfectly safe. The one concern with this, again, is that, well, the one concern with this is that because we're running all this extra voltage, the memory sticks are going to run hotter. And so if you're like in a bad airflow environment or a high ambient air temperature environment, and you want to run a really high refresh interval, this is potentially going to be a problem. Like that's potentially going to harm like the highest refresh interval setting that you can run, in which case you'd actually probably be better off running slightly lower voltage, because refresh interval probably more important than lowering your cast latency by 2 ticks. So yeah, anyway, then we have VDDQ at 1.4 volts. This is quite different from how I would approach a Gigabyte board, right? On Gigabyte boards, I usually run VDDIO and VDDQ the same. I found that with this board, higher VDDQ voltage, like it just likes this value. That's like the annoying thing with DDR5 is like, because the memory speeds are so high, there's quite a lot of variety in terms of like what different motherboards will like different configurations of voltages. So yeah. And this just happens to work best with 1.4 volts. So that's why it is where it is. Anyway, now advanced memory settings, I don't have anything set here. Is there anything below that? Nope. Yeah, the CPU's on auto, so I didn't do anything to the VRM settings. I think... Yeah, oh, I did disable spread spectrum, which should just make the BCLK drift around less. Other than that, didn't do anything there. And so I guess at this point, let's take... Well, I did mess with the... Where is it? There. So I did mess around with the nitro mode a little bit. So this should be faster than like the auto settings as far as I know, but I don't know how much faster. And I did try lower values for these 3 settings right here. Those don't work. So like I tried 0, and actually this one doesn't go below 1. So that one's at 1, and 1 doesn't work on this one. So yeah, theoretically this should slightly reduce the memory latency. This, as far as I know, is basically AMD's version of Intel's round-trip latency timings. I'm not like, I don't like either of these. Well, this makes a lot more sense than the Intel. Well, this is a lot simpler to play with than the Intel round-trip latencies, because in my experience, trying to do, like, in my experience with messing with round-trip latencies on Intel CPUs is that 90% of the time it just causes everything to break if you try to manually set them. So, yeah. Anyway. So that's that. And then for the DDR controller configuration, I didn't do anything. Yeah, that's all on auto. So, yeah, so this is really just like a small, that should help the performance a bit, but I don't have like exhaustive like data for how much it actually helps. But I did set that. And I don't think I changed anything else. Right. Yeah, I didn't. Anyway, so let's take a look at the actual memory timing. So primaries, we're looking at 26, 36, 30. So in my experience, this is basically as tight as you can go on Hynix ADI at 6200. I think I've seen screenshots of tighter timings out there, and I'm going to assume that's just because of better silicon on the actual memory sticks themselves. Because, yeah, like, I was trying to do TRCD35 for a very long time, and I kept getting, like, errors really, really late into stress tests, which was super annoying. And I ultimately decided to go up to 36 after quickly testing 34, and 34 was just completely unusable. So I came to the conclusion that I guess like 35 is not, you know, like if 34 doesn't work like at all, and it would post, but like you couldn't actually like run anything. Like you'd get to the desktop, you'd try to open a full, like before you even really managed to do anything, it would just blue screen. So I guess sometimes it wouldn't even make it into Windows depending on how, you know, long, like I only tried it once and I was like, oh, this is unusable. So if 34 doesn't work basically at all, then 35 is probably right on the edge, and it would be, you know, like easier to just set this to 36. So I did. And TRP was at 28. I ended up bumping it to 30 because I wasn't 100% sure at this point if like TRCD or TRP were the issue. So, and adding 2 more cycles to TRP isn't going to like drastically affect performance. Like in terms of order of importance for the primary timings, TRCD is more important than TCL, TCL more important than TRP, and TRAS almost doesn't matter. So anyway, well, yeah, TRAS almost doesn't matter because like the main reason you lower TRAS is so that you can set like a low TRC. Now for TRC, I just stick to the rule of TRP plus TRAS equals TRC. I am not 100% certain that that rule actually is set in like stone on the AM5 memory controller. On AM4 it was. If you set your TRC really high, you could set your TRAS like impossibly low and the memory controller would just seemingly just ignore the TRAS setting. The AM5 memory controller doesn't seem to do that. So yeah, but like for convenience, I just like to stick to that rule because it does generally work. I'm like, it's also like if you want to experiment with lowering the TRC below like the TRP plus TRAS, you can. I'm just like theoretically it shouldn't do anything to performance, but I haven't really tested for that. And also testing for that is a pain because generally speaking, if you're adjusting any one timing by like, well, small increments, they don't tend to make much of a difference, right? So yeah, anyway, TWR is at 48. Now, funny thing, ASUS, oh, they do actually enforce the TWR limit, so that's interesting. I thought they didn't. But refresh intervals at 65,000. Again, if your memory runs really hot, this is probably not going to work, which is why, I mean, you know, open air test bench with a fan on the RAM, sort of best case scenario for memory temperatures. Whereas if you put your system in a case and you have a big thirsty 4090, it's probably going to cook your memory sticks. Anyway, TRFC, we have that at 477. I think it could actually go lower for Hynix 8i. I just generally don't worry about minimizing this timing because the refresh interval is 65,000 clock cycles. It really doesn't matter. Like, it's not a big deal if you spend 400 or 500 clock cycles out of your 65,000 clock cycles on a refresh, right? Like, just doesn't really matter that much. Now, TRFC2 and TRFC same bank aren't used by the AMD memory controller, so I just leave them on auto because they literally don't affect anything. RTP's at 12. On some kits, you might be able to set it below that, but not mine. Like, I've tried, and on my sticks, like, I've never had success with that. TRRDL's at 8. This is a side effect of me trying to chase down that, like, instability that was probably, like, that was probably TRCD or TRP. With 1.65 volts, honestly, I'd probably expect this to work even at 4 on a lot of memory kits, but it's also worth noting that because DDR5 has a 8-cycle like data burst length, setting your TRRDL below 8 really like doesn't do much to performance. It technically does have give the memory controller the ability to schedule activate commands closer together, but it doesn't actually allow you to squeeze in like a whole extra read burst. So the performance impact of setting either of the TRRD timings below 8 is really, really negligible. And of those two, TRRDL is actually specifically a timing that the memory controller avoids using as much as possible. So yeah, and with DDR5, with how many bank groups you have, that actually means that TRRDL is even less important. Like TRRDL on DDR5 is less impactful than TRRDL was on DDR4 in terms of performance. And even on DDR4, it wasn't really a priority to run it all the way down at 4, right? Like regularly, I would recommend people run like 6.4 for the TRRDs because, yeah, a lot of the time 4.4 would work, but 6.4 performs basically the same as 4.4. And with DDR5, it's like, well, 8.4 performs basically the same as 8.8, actually. Well, 8.8 performs almost the same as like 4.4 for DDR5 because of just changes to how the memory works. So 8.4 is like, yeah, that's fine. T-Fall's at 20. Now, this one, yeah, ASUS does let you set this below the register limit. I am relatively certain the AMD memory controller does not understand what a T-Fall of 1 even is. So I just stick to the, like, minimum value from Gigabyte motherboards. Like, Gigabyte motherboards don't let you set this below 20. As far as I know, because that's the actual, like, register limit for this timing. So, yeah, and setting it below 20, therefore, theoretically, shouldn't actually achieve anything in terms of performance. So I see no reason to set, like, you could set it lower. It just shouldn't really do anything. Because the memory controller is just going to correct that into the lowest, into the lowest actually possible value, which should be 20. Anyway, TWTRL, we're at 16. 4, this is just like, you know, my lazy Hynix timings. I think this could probably go a little bit lower, but I can't, like, it's not going to drastically change performance at this point, so, you know, why bother? Read-to-read SCL is at 4. SC is at 1, so this is just standard single-rank Hynix things. Then we have write-to-write SCL and write-to-write SC at 2.1. Actually, this could probably work with 1.1, but again, like, it's not going to drastically change anything. So, yeah, and then TWRRD, we're at 416. Like, this is very much generic Hynix timings plus some, like, lower primaries, as far as I'm concerned. So, yeah. Anyway, then we have, oh, I have the command, the command bus set to unbuffered, which should be 1T command rate. Interestingly enough, I don't know where the setting for gear down mode is on this board, and I did want to experiment with that, because you might have noticed that, like, with this setup, I was, like, sort of trying to do, like, the nitro settings, and then also setting the command rate to 1. Because I wanted to try something different than just, you know, because I did already do a 6200 CL26 video ages ago on a Gigabyte motherboard. I wanted to try something a little bit, you know, more than that. But yeah, I can't find the command, can't find gear down mode. Not sure, it might be this. I don't know why ASUS insists on always having the wackiest of names for things. And then we have, like, a bunch of extra memory controller settings that ASUS exposes that other manufacturers don't expose. For all of the, like, drive strengths, terminations, and... Well, no, yeah, drive strengths and terminations. That's all this over here is. Those are all on auto. I left power down enabled because I have memory context on auto, which is enabled. Now, theoretically, what you could do, I'm not sure how reliable this would actually be. You could disable power down mode and memory context restore. If you go into DDR training options, run this enabled, and so what training runtime reduction does is it means it's not gonna, like, you're still gonna retrain memory every boot, which is a requirement if you want power down mode to work, or, like, disabling power down mode to work, you need to retrain the memory every boot. But this drastically reduces the training time. So that might be viable if the board is consistent in, like, retraining the same, like, stable settings every time. Is like disabling power down mode, disabling context restore, and then enabling the runtime reduction so that the training doesn't take forever. Because if you don't turn on the runtime reduction, memory training can take like 4 minutes. Or maybe if you have like a really high density setup, even more than that. But anyway, for this, like, I wanted this to be like a sensible daily configuration, so everything's just kind of like on auto there. UCLK is equal to MCLK, right? Because we actually want good performance, not terrible performance. And then we have a bunch more memory controller settings that I don't actually know what these do. Yeah, because I've never seen them on any other motherboards. These kind of look similar to the Nitro mode options. But the names are very different, so... Yeah, I wonder what these do. Because these seem like, well, we'll not worry about that. So anyway, that's kind of it. Yeah, 6200 CL26. At like settings, I would be. Oh, I guess like I have VDDP set to 1.08. I don't really see like this is a so VDDP in my experience does affect like stability for Y cruncher. It doesn't really affect stability for a lot of other things in my experience, and you can have it set too high. So like, though usually I've run into that being a problem at very high memory speeds rather than at like 1-to-1 mode. So like in 2-to-1 mode, if the VDDP voltage is really like is too high, then like Y cruncher complains about it. It takes a while too. Like it doesn't like having the VDDP too high doesn't mean that Y cruncher is going to fail in like a couple seconds. It takes like several minutes, if not even an hour sometimes. So yeah, anyway, the board I think was defaulting to like 1.1 or 1.15. I ended up turning this down to 1.08 because I was trying to fix the Y cruncher instability, which I do believe was originally just the TRCD being slightly too low, but I'm not gonna, you know, like go back and try to like spend hours trying to trace down where the problem originally came from by reverting all of the adjustments. Anyway, yeah, so that's it for this combination here. And honestly, like as far as I'm concerned, this is just like generic Hynix things. Almost considered not bothering to make the video because really the only special thing that I've done as far as I'm concerned is where is it? In like yeah, as far as I'm concerned, the only like extra stuff that I've done here really is not this. It's this. Yeah. That is really the only like, oh, this is different from what I would usually do with Hynix memory on AM5. And I'm not even sure how much of a performance difference this makes. So yeah. Anyway, but the point is like if you are running a 1-to-1 mode setup with like Hynix DIMMs, that might be worth trying, is running the nitro settings at like 1-to-1, because I think on default it tends to default to like 2-3-1 or 1-3-1, something like that, which is going to be a little bit slower. So anyway, there, that's it. Yeah. As for like any like generic DDR5 overclock. Like this is a real issue for me with like making videos about memory, is like it's the same. Like I don't know why everybody keeps making such a big deal out of it. It's like you take a board like, or at least on AMD, I don't know why you'd make such a big deal out of it, because for the most part it's like you just punch in Hynix timings and then you either have to deal with like there were AGSAs where like the memory context restore was really unstable. So you just didn't use it, right? You just turned off memory context restore, and that was the end of the story, because the other option was that your system wouldn't be stable reliably. And that's kind of that. And like the memory context restore issues in my experience at this point have been fixed. I've not run into issues with it recently. But the thing is, at the same time, I have seen cases of like AMD motherboards sometimes like spontaneously just deciding to mistrain. But I don't know like which specific AGSA versions each of those, examples actually used. So I don't know. It might have been like an old AGSA bug. So yeah. I don't know. Hopefully this is somewhat helpful if you have an ASUS motherboard, because like this is basically the same thing as the easy Hynix timings, just like new AGSA. I guess a lot of people might have thought like, oh, new AGSA will allow like 6400 to work, and for me it really doesn't. Okay, like I've tried on a few different boards at this point with this 17900X. And on the old AGSA, this 17900X already did 6200. And on the old AGSA, it also didn't do 6400 at all. Like 6400 was incredibly unstable, Whereas on the newest AGSA, 6400 is just stable enough to take a couple seconds to, like, you can run a little bit of Y Cruncher and then it crashes. Or you can run a little bit of Carhu and then it errors out. It's not stable, and I haven't found, like, a fix for it, and so I don't really see a, like, yeah, I don't see a, well, this CPU evidently doesn't do 6400 as far as I'm concerned. And this CPU isn't even the worst one that I have in terms of memory controller quality. The worst one I have is the 7800X3D in my daily system. That didn't do 6200 on, well, that hasn't done 6200 yet, so anyway, I'm going completely off track at this point. So yeah, that's it for the video. Hopefully you found it somewhat interesting or helpful or something, because I didn't. This generic Hynix timings, whoa, never seen those before. But anyway, that's it. So thanks for watching, and like, share, subscribe, leave any comments, questions, suggestions down in the comment section below if you'd like to support what I do here with actually hardcore overclocking. I have a Patreon, which is how I, like, funded the purchase of this motherboard. And also, like, a Teespring store and a Bandcamp. There's links to that down in the description, so if you check them out, that would be much appreciated. And yeah, that's it. Thanks for watching, and goodbye.